So hello guys and welcome back. So this is my first time that I'm in the video, and let's get started. So in this tutorial I'm going to make a 6-axis robot, and for that I have made some parts, so you need to download it from the description link below. Okay, so I'm just going for assembly now. Okay, directly to the assembly. So just click on product. This is the icon for bringing the existing component in the assembly. So yeah, so here we are. So 6-axis robot is basically used for pick and drop functions, welding purpose, or there are many wide range of applications are there, like you see in the car manufacturing units. So they perform various kind of work over there, and yeah, they are very useful to be in learning perspective. Okay, so for that I'm just first now taking a base. Okay, so it's a base, and now I'm bringing the first joint. So I'm using the manipulation here. This is it. First of all, I'm going to just select this, go for a command called fix component. So by clicking this component will be fixed at its place. Okay, because it's a base, so it should be fixed. Okay, so now I'm going for coincidence constraint. So I'm just coming up here. As you can see, I just gone over here and I got a line, so just selecting this line, and same as for this also. Okay, and now going for command called update, so it will update this thing. Okay, for now just select this again and going for manipulation, and now I'm just sliding it, and now I'm going to apply a command called offset. So just click this, next this one, it should be 0. Okay, and okay, nice. Next I'm going to insert another component here, the second joint. Going for manipulation, and now after that I'm just revolving it somewhat in the x-axis. So let's just see, let's go for y. Yeah, like that. So basically this end should go inside this. Okay, so now I'm going for a coincident constraint. So for that I'm just selecting this command, going here, and same for this also, this one. And now same as done before, I'm going for constraint called offset, clicking the surface and the inner one of 0 offset and click OK and update. So it's totally attached to it. Okay, and now going for the next step, that is inserting another part, which is joint number 3. Going for manipulation, sliding it somewhat and rolling it, should get perfect as that tapo. Yep. Okay, so now doing the same thing again, going for constraint called coincidence, and next this one. Okay, and now I'm going for offset command, this surface and this surface should be contact with each other and update. So it's done. Now I'm going to insert the fourth joint, that is this one. Okay, as you can see, I have changed the name so to simplify it into a bit. Okay, so just sliding it with this command called manipulation. I'm just having this as a reference axis, so I know that where to move and how to tackle. Okay, and now I'm just giving the constraints and that's it. So going for coincidence constraint, selecting this one, same for this, clicking on update. Now going for a command called offset constraint, select this one and this surface which is facing to it, and now give the dimension offset 10 mm. So it will look like this. Okay, and now I'm just using the command called manipulation again for this in the drag around z-axis, so it will move up. Update, so we can fix another component here. Now inserting the another joint, which is joint number 5, and manipulating it. Okay, and now going for coincidence constraint. And update, offset constraint, zero mm, update. Okay, and now like you can add anything in here, like L shape, two L shape angles, so you can pick and draw function or anything like to perform different kinds of operations. Okay, so this is our basic part construction, and now we are going to give its motion. Now we are heading to give it a motion, so we are selecting digital mockup and DMU Kinematics. And in this session I'm going to showcase how to use the Revolute command. Okay, so here it is, a Revolute joint. So I'm just clicking on new mechanism, so it will develop a tree here. So pressing OK, and now focusing on the first joint that we made. So I'm just hiding this, and first line, which is the center line of the second part, and the base like this. And again coming back, I'm selecting the surface, this one, and this one, which is the center of it. Okay, and it should be angle driven. Okay, show like this. So I'm going to make a similar process into this, that one, and this one. So 3 joints of a same command, which is a Revolute joint. Okay. Make sure you carry on the process very carefully, because first two lines, then two surfaces is the only rule. Okay, like it consider the planes, like this plane and that plane. Okay, angle driven, and okay, show this, it will back into the workspace. Similarly here also, hiding this one. So by this way I have applied the joints mechanism. Okay, and now it's time to check the components. Make sure everything is intact and as per the tree. Okay, and now I'm going for simulation. Okay, so for that I'm going to create an auto create. Okay, simulation, this one, and it will display a chart like this. So first of all I'm just testing it. So just okay, and the second joint like this. Okay, I haven't unhide this. Okay, now back. And now I'm going to insert it so we can see the actual animation or simulation that is going to happen right now. I'm just decreasing the frame rates so you can see that clearly. So it's totally functioned. If you like this video, just click a thumbs up button and please subscribe to my channel to get more update, and have a good day.